Okay, so today's video is going to be relatively short. We are covering balancing equations, and we're just, again, this is, the science class is a 2-credit class, so basically it's kind of like 1 credit of chemistry and 1 credit of physics, basically. So we just kind of skim a lot of topics. Alright, with that being said, and we'll dig a little bit deeper as we get in more into the acid-base stuff, and then again with physics a little bit deeper too. So we have this laws of conservation, and in one of them it's kind of more of a basic one, saying in an ordinary chemical reaction, matter is neither created nor destroyed. So it's basically kind of rearranged, is kind of a way of looking at it. And the laws of conservation of mass, according to this law, the mass of the products in a chemical reaction must equal the mass of the reactants. So again, nothing is really destroyed, it's just kind of rearranged basically. And you'll see kind of what that means here when we're talking, when we balance equations. So the numbers of the elements still need to be the same on each side to be considered balanced. Alright, so talking about chemical bonds, we kind of talked about this in the last video, how elements are most stable when their outermost shell is filled with electrons. Okay, so if you have the outermost shell is missing an electron, then it's considered unstable or not as stable. However, not all elements have enough electrons to fill their outermost shells. Atoms then form chemical bonds with other atoms by obtaining the electrons that they need to make a stable electron configuration. So atoms can form molecules by either donating, accepting, or sharing electrons to fill their outer shells, because that's kind of like their goal basically, to become stable. So when we look at hydrogen here and oxygen, so we're looking at 2 hydrogen elements here on the left side, basically not attached yet to the oxygen, and then they go ahead and they join, they share, they help fill the oxygen's outermost shell. Okay, so so when these 2 hydrogen ions in the oxygen share these electrons, this is called a covalent bond, and a water molecule then is formed. So the bond there, that's the white and the red color off of the hydrogen, how they're sharing that outermost shell there. They're helping fill basically oxygen's outermost shell, and that bond there is a covalent bond. And remember, those are the strongest bonds. So chemical reactions occur when 2 or more atoms bond together to form molecules, or when the bonded molecules are broken apart. Okay, so then that causes a chemical reaction. So the substances, this is kind of again like terminology basically. So the substances used in the beginning of a chemical reaction are called the reactants. So the reactants then are on the left side of this equation. So we have 2 hydrogens and 1 oxygen. So those are the reactants. And then the substances that are found at the end of the reaction then are known as the products. So your H2O then is considered your product. Alright, so here's an example of a balanced equation. Okay, so this is a simple chemical reaction, is breaking down hydrogen peroxide. Okay, so you have 2 hydrogen peroxides, which then can be broken down to 2 waters and 1 oxygen. So if you look at this in math, if you look at the math of this to determine how they're equal to a balanced equation, so if you're looking at 2, then the H2O2, okay, so that's 2 hydrogen peroxides, but let's just look at the hydrogen on the left side. So if we're looking at the hydrogen on the right side, we basically have 4 hydrogens. So you take the 2 times the 2. Okay, so the big 2 times the little 2 gives you 4 hydrogens. Okay, if you look on the right side, you have the same. You have 2 times the little 2, the big 2 times the little 2. Okay, so you have 4 hydrogens in it, both sides. So this is how you're counting to see if it's equal. And then on the left side, you have 2 oxygens, because oxygen is generally oxygen is O2. It's not usually seen by itself, just an O, unless it's mixed with something else. But so O2, okay, and then if you look over on, so again, sorry, I think I misspoke there. So we're looking still at the left side. So we have O2, but then we have 2. We still have to keep in consideration that big 2 in front of the H, because that plays into how many oxygens are on the left side. So again, you're going to take that big 2, which is on the left side of the H, multiply it by the little 2 by the O, and that gives you 4 oxygens. And then if you look at the right side of the equation, we have H2O, but we have a big 2 in front of the H2O, and so that actually contributes to 2 O's on the water part, and then you have the O2 for oxygen, so you have 2 plus 2 equals 4. Okay, actually, let me get out my little pen. Bear with this, I know this is horrible. So here we have 4 hydrogens. Okay, and then we go over here and we look at the 2 times the 2. That gives us 4 hydrogens again on this side. Oh, it looks like a Y, it's a 4. Okay, and now we have the 2 times the O2. Okay, so that's going to give us 4 oxygens. And then we have 2 times the O here. So there's 2 there, and then there's the 2 here. Because between this one and this one, we're going to get 4 oxygens. Okay. Alright, so hopefully that helps out. I have some video links for you guys to go over to help you with this too. Because that's basically your homework from this lecture, is balancing equations. And maybe some of you did it in chemistry in high school and you remember, hopefully. Okay, so how does this apply to us as respiratory therapists? So we are looking at, in this particular equation is the carbonic acid equation. Okay, so in human blood, and so basically, like the other H2O2 with hydrogen peroxide, that formula can actually go back and forth. So all these formulas, they can go back and forth to try to establish equilibrium. And just I wanted to add, I forgot to add a comment about hydrogen peroxide, just a little tidbit, trivia of information. The reason that hydrogen peroxide works really well with infections in that is because it has that extra oxygen. So like water is H2O, okay, H2O, but hydrogen peroxide is H2O2. So you have that extra oxygen molecule. And my dentist actually told me that. He said that's why, you know, when you have like a little gum irritation or something, or any kind of irritation in your mouth, if you use hydrogen peroxide, that most of those bacteria or whatever are anaerobic. They don't like oxygen. So if you put hydrogen peroxide, and other infections too for that matter, that extra oxygen molecule in the hydrogen peroxide is what helps kill the bacteria. So just a little piece of trivia there. Alright, so we're looking at the carbonic acid equation here. And so in human blood we have an excess of hydrogen ions bind to bicarb. So we have the hydrogen and the bicarb. Your bicarb there in that top part of that equation is your HCO3. Okay, that's bicarbonate. Okay, so then that forms together with the hydrogen, and then the H2CO3 then is carbonic acid. Okay, carbonic acid can also leave the body. Okay, so this is kind of how it's broken down then. It leaves the body as CO2 in gas. So on your right side of the equation on the bottom line there, it breaks down then into CO2 and water. Okay, so we get rid of the CO2 by exhaling. So it can also leave by exhaling instead of being converted back to bicarbonate ion, which is on the left side. So these reactions are important in maintaining the homeostasis of our blood. Okay, so you'll become very familiar with this equation. So this is the carbonic acid equation. Okay, so this is what happens during cellular respiration, basically. So cellular respiration involves many biochemical reactions. However, it can be kind of summed up in the chemical equation there below, and I'll talk about that here in just a minute. So what we're looking at is, this is kind of where the law of conservation comes into play. Matter can be neither created nor destroyed. So there must be an equal number of atoms on each element on both sides of the reaction. So this is where what happens here, and as a result, energy is released. So cellular respiration releases energy in the form of ATP, during its chemical reaction. So cellular respiration is performed in cells, and it's the reason that we eat. We eat so that we can deliver glucose to the cells, and then we breathe in order to deliver oxygen to the cells. So we're basically looking at your C6H12O6, okay, that is glucose, okay, so that's the chemical of glucose, plus oxygen, okay, so you have 6 oxygen molecules, yields to basically carbon dioxide, water, and energy. Okay. This is also covered in chapter 2 of your A&P book. So I highly recommend you definitely hit the link there, and I know if you go back into the regular view of this PowerPoint without the audio part, if you go back to course content on day 4 in chemistry, there'll be another tab that you can click on that just has the PowerPoint in regular view form. And if you click on this link, this is actually Khan Academy explaining cellular respiration. And watch it till it's like a little over 14 minutes. After about 12 minutes, he starts talking about stuff that we don't get into. So, you know, the first 12 minutes is good, solid information. So just focus on that, because that's a lot of information in itself. So again, this is also covered in your A&P book on chapters 2. So I'm going to talk a little bit about this again. So, cellular respiration is important, not just to produce carbon dioxide and water, but CO2 is a waste product that we actually get rid of by exhaling, and also producing water. We can also get water obviously from drinking. The reason our cells perform cellular respiration is to release energy. That's one of the key things within the bonds of the glucose molecule. So that's one of the biggest things. And then this energy released from the glucose molecule in cellular respiration must be converted to a usable form. And the usable form then is your ATP. And as he explains, your ATP is basically your energy currency. That's usually what it's broken down to be exchanged for your energy. So that's the unit anyway. Okay, so in the YouTube video from Khan Academy, he kind of talks about all of this here. So you can kind of refer back to this, because I know it's really super busy right now, but you can refer back to this to see kind of what he's talking about, to kind of give a visual. I mean, of course he's drawing, which is very helpful while he's speaking too, but it kind of talks about glycolysis, the Krebs cycle, and then the electron transport chain. Okay, so he talks about these three different things. So glycolysis, I'm just going to add a few notes that I basically got from watching the video. So glycolysis is anaerobic. It really does not require any oxygen. Okay, and you're in glycolysis, you're breaking up the glucose. Okay, is basically what that means. You're breaking up the glucose, and no oxygen is required for glycolysis. It needs 2 ATP to happen. It generates 4 ATP and gives us a net of 2 ATP. I'm not going to quiz you on that or test you on that. I just want you to be aware of the terminology. Okay, and then the Krebs cycle over on the right side, that does require oxygen. The Krebs cycle is aerobic. Okay, so it does require oxygen. And then the electron transport chain towards the top right there, that is also aerobic, and it produces basically the bulk of the ATP. So there's about 34 ATP, and he kind of talks about how those numbers, 38 overall, is kind of a ballpark number, but that's where the bulk of the ATP is produced, is in the electron transport chain. So your glycolysis breaks up the glucose, and it's basically the first stage of cellular respiration. So the energy released during cellular respiration is used to form ATP, and again, ATP is the energy currency. So ATP is used to heat our body, provide electrical impulses in the brain, and to help us contract muscles. Okay. So that is really all I'm going to say about that, because I think Khan Academy does a good job for the level of what we need to know. And then on these video links here too, I want you to look at these, because these will help you with the balancing equations. Okay, so there's 3 different video links here to help you with the balancing equation part of your homework. And again, please feel free to email me with questions. Thank you.